So for our lab exercise, we're basically going to implement the parentheses stack that we had discussed above. We'll be using these files. Balance.cpp will be the only file that you need to change. Stack.cpp and stack.h contain an array implementation of a stack. Item.h will contain some other definitions. Your primary tasks are going to be to fix the bug that occurs when there are open parentheses but no corresponding closing parentheses. Essentially, you have a partial implementation that doesn't recognize that it's not well formed if there are still items in the stack. So you're going to need to add some control to determine if the stack still has items in it when the program's over, that it's not what you wanted. And we also want you to create exception handling so that there's no error that occurs if the stack is full and you try to push something down onto it again. So your steps will include first off just running the executable and seeing what kind of results you can get. You should find a couple of incorrect results as you go along because there's problems with the algorithms. As I mentioned, it doesn't recognize that having items in the stack is not well formed, so you might want to fix that first. And such as in test case number 7, that will exceed the limit of the stack. To fix that, we want you to use exception handling to catch the full stack exception. Information on exception handling can be found here. Essentially, an exception is an unusual event, usually an error, that requires special processing. Usually this type of thing would crash your program if you didn't pay attention to it. You can handle exceptions with try, catch, and throw statements. A try clause encloses a code in which an exception might occur. Throw signals the fact that an exception has occurred and control needs to be passed to the exception handler, and catch processes the exception. So each catch clause is an exception handler. So to throw or raise an exception, use the throw statement, which just has the syntax of throw expression. Specifically in this lab, we were asking you to use exception handling for if the stack was full, and also for if the stack is empty. So when something is being pushed down onto the stack and it's already full, you want to throw the full stack exception. Now these are both implemented as exception classes and they're already defined in stack.h. So you don't need to worry about defining the exception class. We already have that. So the try catch statement is if one part of your program throws an exception, another part should catch it and process it, which is the try catch part of it. The general syntax is you try to do the block of code, so you try, say, to push something onto the stack. If it doesn't work for some reason, you catch the exception and you do something about it. So the syntax is a try clause followed by one or more catch clauses. The block may be any number of statements between a set of curly braces. When a statement or a group of statements might result in exception, we enclose them in the try clause. So enclose pushing the stack in a try clause, for example. And for each type of exception that can be produced by the statements in the try clause, we write a different catch clause. So you want to make sure that all exceptions are caught, and uncaught exception can completely crash your program. So we have an example of some try-catch code here. This is for an exception of dividing by 0. So you have your exception class here. And you can see they enter the numerator and denominator, and then they try to divide. If the number is 0, then they throw the 0 division. Or else if it's not 0, they just do the division and see out the quotient. And the catch for trying to divide by 0 is defined down here. So try, catch. It see outs that you can't divide by 0. So for this lab, you need to modify balance so that it has a try clause. You'll need to figure out what part of the code you should be adding that try clause to. And you'll want to catch the clause for a full stack. So what it should do if the stack is full, which is essentially just print out that the stack is full and that you can't add anything else to it. That's what your catch should do in this case. And once you have those problems fixed, just make sure to try out all of these different test cases.